Hello everyone, I am Narendra Kumar Sharma, currently pursuing my Bachelor's of Technology in Specialization in Electronics and Communication Engineering from National Institute of Technology, Hamirpur. I am currently an intern at Emertxe Information Technologies.
Hello everyone, myself Saket thakur. I am currently pursuing my BTech degree in Computer Science and Engineering from NIT Hamirpur. I am currently doing intern at Emertxe Information Technologies. Now, Vishal will continue with the introduction.
We are currently doing an IoT internship at Emerges. We learned a lot in our 7 week journey. As we are beginner in this field, we explored a lot. For us, our mentors have a well structured weekly mentorship from the basic to the advanced in IoT. This is a project oriented internship, and that is the best way to learn something from scratch. Our mentors are very helpful as we are from around the globe. We have a student discussion forum where we can interact with each other. We have weekly quiz test, and the student who perform outstandingly in that quiz were rewarded with goodies. We have two kickoff meetings, or we can say onboard meetings. Now, my teammate will present the presentation.
Now, starting with IoT based home automation solution. So, content of this project. Purpose. The purpose of the document is to understand the requirements of home automation using Arduino, PiximLab, and Blink application. This document can be used by the students to develop the project. This document will also be used for requirement validation. So what is the scope? The home automation should be simulated on the Pixim simulator, Blink IoT, mobile application used to control the devices. Should be able to control the lights, temperature of the home, inflow and outflow of the water in the water tank. Assumption. All the peripherals are simulated and no real-time objects are interfaced. Dependencies. Based on Blink mobile app. So, table of the content. About the project. It's IoT-based home automation using Arduino Uno and PiximLab. Major requirements were Arduino Uno, PiximLab, and serial communication. Project goals. To make a home automation solution. Sneak peek. We are using PiximLab, IoT Blink Cloud Services. Project stages. This project consists of 3 stages. They are IoT solution. So now, approach to the project. Using Blink IoT application and Pixim simulator, simulated home automation where LED, temperature system, serial tank resembles light, heater, cooler and water tank in the real time. CLCD act like a dashboard used for displaying the events. Widgets from Blink IoT app like button widget are used to control the heater and cooler, inlet valve and outer valve. Gauge widget is used to display the temperature and the volume of the water. So now, what are we working on? Arduino IDE. In Arduino IDE, we write the code of our project for the hardware part, that is our Arduino. PiximLab. PiximLab is an open source software that is used to simulate hardware project and run the code on it. Implement it on simulation. Virtual comport. Using virtual comport, we basically connect our PiximLab virtually Arduino to serial terminal of Arduino IDE. IoT Blink app. Blink is a platform used to make IoT apps for testing, and it also provides cloud features to us so that we can retrieve the data from the server and store it on our app. So, what is a smart home? Having garden lights control, light control using LDR, water inlet and outlet. So, we are controlling our garden lights using value of lights hitting on our sensor. Our sensor is LDR, which is light diode resistor, which use the amount of heat by the resistant heat. We calculate amount of light and operate accordingly. Water inlet and outlet. For water inlet and outlet, we use the sensor valve that take the calculation of amount of water remaining in the water tank. So about the project. In this project, we are providing the modern solution, or we can say automated solution of home automation using Arduino, virtual port, PiximLab simulator, and Blink app to make it functional. So what are the major requirements? So here we have a pie chart. and dependencies as a percentage, we can say Blink app is 30% dependent, Arduino ID 55, and PiximLab 15% dependent. So now let's see the timeline. Week 1. In week 1, it's all about intro and explanation of the project. So we began with the basics of C programming from intro to C programming language, data types and operators. Then we learned pointer, function, recursion, string and storage classes. In week 2, it's all about programming language, preprocessor introduction to C++, difference between C and C++. Then interesting topic came, that is object-oriented programming. In OOPS, we gone through class, object creation, constructor, destructor, and finally in second week, we have our first introduction to IoT. Had a meet in which we introduced the project and embedded systems. Our project is IoT based home automation. The home automation should be simulated on Pixim Simulator. Blink IoT app used to control the devices. We should be able to control the lights, temperature of the home, inflow and outflow of the water tank. Then we install the all the dependencies which we are going to use in our project. These are Pixim Lab. It is used to simulate hardware. In this, we place our hardware component and make a connection virtually, then upload our hex file in desired microcontroller. Null emulator. Null emulator is like a virtual port COM connection to establish a virtual COM connection. Arduino IDE. As we are using Arduino as our microcontroller, so we have to program that. For that purpose, we are using Arduino IDE to program our microcontroller and generate hex file. We done some basic LED programming in week 2 also. In week 3, we learned about OOPS concept and various levels of the project. We begin how to program LCD. We write a program to control LED using LDR, heating using temperature sensor. In week 4, we started with the project, installing dependencies, and we code our root file and integrated with child files. Made a Blink app which is platform for IoT developer. We coded Blink app according to our need. The output received from the Pixim lab is showed in the app to verify our project is working correctly. In week 5, we finally completed the project and compiled it. We also gone through the Disha workshop and we learned about what are the scope of IoT in future and also learned how to make a decent CV. So, learning outcomes from IoT internship. In first week, learn about C programs. Our mentor taught us effective manners. We have our own student dashboard. In second weeks, it's OOPS, C++, and everything else. In third week, we learn the requirements of the project, Pixim Lab, uh, Virtual Compost, Blink app. In fourth week, we begin with implementation and coding part. Fifth week, we finally done the hardware part. And in sixth and seventh, we have the show workshop and interesting session about the CV making. And we completed the internship in sixth and seventh week. So, project goal. Goal to write the code for our Arduino and load our hex file to Pixim Simulator. In second half, we built a Blink app to run our device and testing it on our simulator. So, a sneak peek. They are the components we are using in our home automation system. We are using LEDs for lights, CLCD for display part, fan, water tank, indicator for inlet and outlet valve. So, project stages. It's all about Arduino ID and code of our project. That was a stage 1. In stage 2, it's all about our simulation. We load hex file, binary file to Arduino Uno. In stage 3, we basically connect to Blink Cloud platform and make a Blink app for our project so that we can communicate with our project. Now, my friend Render will continue with the codes that we created for in Arduino Uno.
Yes. Uh, Saket, please present the Arduino ID code.
Wait a second.
Yeah. Yeah. As we move to coding, here we are with Arduino ID. In this code, we have a Blink template ID, which is generated when we made entry on Blink Cloud. Then we have a device name registered on the cloud authorization token, which is a private key to access the cloud. Then we have when we import a Blink a simple Ethernet, which is a library of Blink to communicate with virtual ports. Then we have included liquid crystal library for the interface with LCD. Then we stored our private key in character array. We initialize Boolean variables for input and output that will switch the states of our output, which is 0 or 1 simply. Then we set our LCD addresses for 16 characters, and it is a two-line display, so we have to set accordingly. To turn on and off the cooler, it is based on the pin value, which is virtually connected to Pixin lab, which give us the state, either it is 0 or 1. To turn on and off, it is now we wrote this function, and as the value is true, then it is in on state, and the vice versa. Then same goes for the heater and inlet outlet valve of the tank. This is the function part. Second, can you, yeah, can you scroll down, like, okay, okay. This is the functioning part of our home automation to get notified in Blink. uh, can you move down? Yes, yes, fine. To get notified in Blink application, we write a function to change the temperature or update the temperature, we can say. Similarly, we write this function for our heater. Uh, can we move down? Okay, here is the function for the uh, heater and the tank. Can we move to the while loop? Huh. Here it is. Then we write the function for the tank volume, and then we integrate our all the child function to our main while loop, you know, and the external files in the root application, root file. Uh, Now my teammate Saket will continue.
Starting with main.h. Here, we have defined various virtual pins for temperature gauge, cooler V pin, heater V pin, water volume gauge, inlet V pin, outlet V pin, and blink terminal V pin. Now, moving to temperature system.h file. Here, we have virtual pin 5 for heater and 4 for cooler. And we have analog input A0 for temperature sensor. And various functions for temperature like read temperature, init temperature system, cooler controls, and heater controls. In temperature system.cpp, we coded the various functions defined in temperature system.h. As we can see, we included temperature system.h header file. So we used pin mode, cooler output, pin mode, digital write. In function read temperature, here we read the temperature and return the temperature, which will be shown on our CLCD. So other two functions are cooler controls and heater controls, which will show the coolers and heaters readings. So now moving on to LDR.h. Here we have LDR sensor having analog input A1, garden lights with virtual bin 3, and two functions init LDR and brightness control. In LDR.cpp, we included LDR.h, Arduino.h, and main.h. So In init LDR, we use this bin mode garner lights output. For brightness control, we calculate in this function, we calculate the threshold value, which act as an on and off value for garden lights. We can say it will show at which value the garden lights will be turned on and off. So moving on to serial tank.h. In serial tank.h, we have defined inlet valve, outlet valve, high float, low float, volume, enable, disable. And these are the addresses of all these values. And we have functions like init serial tank, enable inlet, enable outlet, disable inlet, disable outlet, and volume. So in serial tank.cpp, here we have coded for various functions like serial begin and serial write for init serial tank. And we can say we have here serial write for volume. We read the volume and return the volume value. So we use in enable inlet function, we have written serial write inlet valve and enabling it. And for disabling inlet, we have disabled the outlet inlet. Sorry. So in enable outlet, we enable the outlet, and disable outlet, we disable the outlet. So that's all about our coding part. So now let's see the execution of our project. So we can do like this. It is compiling, and now we can export the compiled binary. And you can see it is compiled successfully, and we can go to here. Here we can load the hex file. You can see it is getting starting from scratch, and it is loaded successfully. Now I'm using my Blink app on my phone. First, I will show you the execution of the Pixim Lab and the serial tank. Then I will show the Blink Lab, Blink app execution, as it is not possible to display both at the same time. So I turned my heater on, and you can see the temperature is rising. And 35 is the threshold value, and heater turned off. And when the cooler is on, temperature goes down, and at a certain temperature it remains constant. So now for tank is concerned, here I started the inlet valve and water level is rising. As soon as the water tank is full, the inlet valve is turned off, and we get the notification water level is less than 2000. Water level is 3000. Water level is inflow disabled. Now I turn down the outlet valve, and we can see the water level is going down. As soon as the water level reaches below 2000, the inlet valve turns off, and we got the notification water inflow enabled. Here we have made the connections using COM1 port. We have CLCD, LDR, LED, temperature cooler, Pixim Lab, serial tank. Now I will show the Blink Lab execution. Let me just join the meet from my mobile phone. So So here, the inlet is on and inlet is off at 3000. So I turn on the outlet and it stops at 1970. And we get the notification. Here you can see the all the notifications. For now, heater. Heater is on and it gets turned off at 35. So I can turn on the cooler. Here we can see the notification we get from heater is off. And when temperature comes down, it remains constant and we can turn off the cooler.
Yeah, that is from our side, and that is the output of our project. Mm, Thank you.